Hello students, and welcome to the continuing lesson on parametric equations. And in this video we are going to look at how do we deal with parametric curves, and particularly curves that are in circular type of graphs. Okay, so it's a graph that's going to look like a circle. So I have a question here that says to eliminate the parameters, and just to remind you that when we're done we should eliminate the parameter. Here means to eliminate t, and we should get one equation with only x and y. Okay, that's what we're really doing here. So we have three variables, x, y, and t, and we need a way to just get x and y and not have t. And so one of the first things I'm going to do is just graph in parametric mode, just to see what it looks like. Okay, so I just want to see what this equation, this parametric equation is going to look like. So let me bring up my TI-83 calculator here, or this is actually the 384. Okay. And one of the things I'm going to do here, I'm going to go into mode. And there's a lot of things going on in my calculator that you might not have on yours, but one of the things we want to point out is that I am graphing in Radian mode right now. And your calculator may say function, you want it to say parametric. Okay. And now we can start graphing. So I am going to, the first equation is 2 cosine t, and then second equation is 2 sine t. I'm going to look at my window here, and notice that since we are in radian mode, you want to make t between 0 and 2 pi. You can certainly do more than that, but I'm going to go up to 2 pi. And then for the t step, I'm going to go at 1/10. So this is 1/10 of a radian. Okay? The reason for this is if I make t step really big, the graph will be inaccurate. If I make t step very small, it will take a very long time to graph. The x min and x max, I'm going to go maybe just negative 5 to positive 5. I don't think I need to go up to 10. Okay? And the more experience you get graphing this, the better you will get at picking the right window. Okay, so now I'm going to hit graph. And you can see the picture forming here, and this is a circle with a radius of, looks like it's a radius of 2, 1, 2, 1, 2. And it looks a little bit like an oval here. That's only because my window is, the graphing window on your calculator is a rectangle. It's not a perfect square, so it's a little bit longer than the height. So it's going to look a little bit stretched out, but this is a circle of radius 2. Okay. And knowing that will help us a lot. So we know that this is circle, center at 0, 0, and a radius of 2. So that means once we're done solving this equation, once we're done eliminating the parameter, we should get an equation that represents a circle. Okay. So without further ado, let's get to work here. And my strategy is going to be to use Pythagorean identity, okay, to eliminate t. So this is tricky because t is inside of a trigonometric function. T is inside of another trigonometric function, and the only way to handle this is to get rid of t is to use a trigonometric identity. In other words, the Pythagorean identity. So I'm going to square both sides. I'm going to get x squared equals 4 cosine squared t. Y squared equals 4 cosine squared t. Okay, so all I did there was square both sides. Now I'm going to divide everything by 4. And keep in mind, I want to isolate cosine squared and sine squared. So I made a typo here. This should not be cosine squared. This should be sine squared t. So we're going to divide everything by 4. and I'm still working with two different equations here. I get x squared over 4 equals cosine squared t. Y squared over 4 equals sine squared t. And then I'm going to add the two equations together. So add equations. And there's nothing wrong with adding equations as long as you add the left side and you add the right side. So I'm going to get x squared over 4 plus y squared over 4 equals cosine squared t plus sine squared t. Okay. And just to make things a little bit simpler, I'm going to combine these two because they are in fact the same denominator. So x squared plus y squared over 4 is equal to cosine squared t plus sine squared t. And now use the Pythagorean identity. Okay, so use this Pythagorean identity down here. The left side of the equation stays exactly the same. X squared plus y squared over 4. But on the right side, I know that this here is equal to 1. Okay. And now we have eliminated t. So in my final step, just to clean this up a little bit, I'm going to multiply both sides by 4 and get x squared plus y squared equals 4. And there you have it. We started out with two parametric equations, the advantage being that we can graph them, and then we finish with an equation that uses only x and y. The advantage here being that we may be able to do algebra a little bit easier with 2 variables than 3 variables. And to verify, right, when we graphed it before, we realized that this was going to be a circle with a center of 0, 0 and a radius of 2. This equation really is a circle, if you remember the equations for a circle, with a center 0, 0 and a radius of 2. Okay, so it certainly helps if you check first by graphing, so that when you're done with your equation, you can tell what it's going to look like and whether you've done all of the work correctly. All right, students, thank you for watching this video and have a wonderful day or a wonderful evening. I'm going to continue on here, though, and post one more video where we actually go backwards, where we're given an equation of a circle and we work backwards towards the parametric equation.